A very warm welcome to our session here. We are excited to have you joining us in SkillsFuture Month at SIT. I am Clarice, an undergraduate student from SIT. I will be a student host for this session. The title of this session is Live, Work, Play with Intelligent Robots. We are honored to have our speaker from NUS ISS, Dr. Nicholas Ho, who will be speaking to us. The session will be moderated by Mr. Koo Yap Ming. Dr. Nicholas Ho is currently a lecturer at NUS Institute of System Science. He received his bachelor's in engineering and PhD degree from School of Mechanical Engineering, National University of Singapore. Experienced in the mechanical engineering field, he specializes in state-of-the-art Industrial 4.0 technologies such as cyber physical systems, Internet of Things, augmented or virtual reality, and artificial intelligence. Prior to joining ISS, he spent a number of years in research, whereby he assisted in the development of cutting-edge CPS and IoT technologies, a novel VR training system, and groundbreaking optimization models for biofabrication applications. Without further ado, let us welcome our speaker, Dr. Nicholas Ho.
Thank you, Clarice. Right, I'm Nicholas, and I'm here to run through this session with you. Live, work, play with intelligent robots. Welcome, everybody. Okay, so a little bit more about myself. I believe Clarice has already introduced me, but just a little bit more introduction. Okay, so I'm from this organization, NUS ISS. Okay, so if you want to know more, you can look it up in Google. Right, you can easily check out the website that we have and to know more about us. Okay, I'm currently a lecturer at NUSISS and mainly teach robotics related courses. Okay, and I believe the rest of the details have been covered by Clarice already. I'll not go through them. Okay, so for this session, I'll run through all these contents. Firstly, an introduction of what is an intelligent robot and how to differentiate robots from plain simple machines. And following which, we will be running through some of the applications, both present applications that we have been seeing around us, as well as a futuristic application that we would like to see in the future. And following which also some of the state-of-the-art technologies such as LiDAR and ROS, right? More on that later on. And the second last point, right, we'll be going through our very own robots that we have in our courses, okay, such as the Turbot tree and a robotic arm known as the Open Manipulator X. And last but not least, this session will end with a virtual demonstration of autonomous robots based on the Turtlebot tree. So to start off, let me give you an introduction, right? What is an intelligent robot? Okay, so the question is the intelligent word here redundant? Okay, because as I think most of you have understand, right? Robot by default, right, are intelligent. Okay, so why do we still put intelligent as at some point of time at in especially for people in my industry? Okay, and the reason to that is because I think many people at this point they still do not right know how to differentiate between robots and plain simple machine. Okay, so most of the time we'll tend to put intelligent in front of the robot just to emphasize on this point that robots right are by default intelligent. Okay, so with that, let me just give a very brief comparison between robots as well, versus machines. Okay, so robot, as I mentioned just now, they are intelligent, right? They are more intelligent as compared to machines. They are able to think, they are able to learn, as well as they are able to adapt. Okay, and in summary, they are right? Or rather, they have a high level of autonomy as compared to machines, right? And not only in terms of intelligence, right? In terms of perception, right? Robots have a high level of perception as compared to machines, okay? And uh, in most of the robots, right? Or rather, most of our robots, okay, sensory systems are necessary, right? And is a very essential part of robotic systems, right? Whereas for machine, it is not necessary to have sensory systems around. Okay, so these two are the main point. Firstly, is more intelligent, and secondly, it has a higher level of perception as compared to plain machine devices. Okay, and because of its intelligence and perception, or rather higher level of perception, robots are able to perform a larger variety of tasks. Okay, so making it more versatile than normal machines. And of course, because of its intelligence and higher level of perception, and is more versatile than machines, it require more design and development work as compared to normal machines. Okay, so I think with this, I hope you are able to clearly differentiate, right, the difference between machines and robots, right, which are by default intelligent. So moving forward, let me just allow to share some of the broad classification that you can that we can classify robots into. Okay, so firstly, we can classify robot into whether uh, they are mobile or not. Okay, so with is summarized by this definition known as locomotion. Okay, so locomotion by definition, it means the mobility of the robot, right? Or rather, to move the robot around. Okay, and on the other hand, we have another group of robots in another category known as the manipulators. This group of robots usually fixed around a certain point and is unable to move around. Hence, it is only able to move the other objects around its fixed position, okay, or within its workspace, right? So two main categories: mobile robots, right, as well as manipulators. On the other hand, robots can also be classified by its level of autonomy. Okay, so looking at this table over here, we have the least autonomous level, right, which the non-programmable robots belong to, right? So what I mean by non-programmable robots, this group of robots, once installed, they are unable to be reconfigured, they're unable to be reprogrammed to do other tasks. Okay, so very little flexibility over here, right? Following which, the next in line, right, which has more autonomy, which are the programmable robots. Okay, so these robots can be reprogrammed by developers, right, to do a different range of tasks. Okay, and the third level, right, which has a higher autonomy compared to the previous two, right, which is known as adaptive robots. Right, these robots are coupled with sensory system, right, to make the robot to be adaptive to its environment. Okay, but however, this group of robots, they are not intelligent enough. Okay, because they still require human intervention in terms of either development, right, or in terms of other aspects. Okay, of course, the most autonomous level, right, belongs to the intelligent robots, where very minimal or no human intervention is required. Okay, so two ways to classify. Just a bit of recap. Number one, the to classify into whether the robot is mobile or not, and number two, whether the robot has a high level of autonomy or not. Okay, so moving forward, let me give a brief run through of the five levels of autonomous driving. Okay, and these five levels is actually being brought up or rather developed by SAE, right? So this is a well-known standard among the autonomous vehicle industry, okay, whereby a lot of industry players refer to this standard, right? Okay, and how to look at this chart over here? Okay, so you look at level 0. This does not belong to any of the level, okay, because it is fully manual driven by the driver. Okay, so no aspect of autonomous driving over here. Okay, and if we look at level 1 and 2, okay, so level 1 and 2, you can actually observe them, right, in some of the vehicles nowadays, okay, especially in those more expensive vehicles, right, whereby functionalities such as adaptive cruise control or lane keeping assistance are being in place. Okay, and moving forward, level 3 and 4 autonomous vehicles, this is not fully launched right out there in the roads right now. Okay, so some of the industry players in the US, right, include like Waymo or Tesla. Okay, currently they are on pilot tests, right? Whereas for Singapore context, right, if you go to One North, right, you're able to see some of these self-driving cars on pilot tests. Okay, look out for this company called Nunotomy. Okay, they have several cars going around the area doing pilot tests. Okay, but nevertheless, now for now, right, level 3 and 4 is not being launched on a full scale. Okay, currently it's still on pilot test phase. All right. As for the last one, level 5, okay, so to my knowledge, none of the companies have actually reached to this level yet, whereby, okay, whereby there's no driver or rather human driver intervention. Okay, so what I mean by that is that all the seats, right, are all made passenger seats, right, facing each other. So there's no driver in place to intervene, right, in the event if the autonomous car cannot continue driving. Okay, so more on that later to compare between level 3 and 4 versus level 5 autonomous car. Okay, so that's the end of the introduction. We'll move on to present applications in three various categories: live, work, and play. Okay, so we have some examples here, right? So in the live category, for example, our very own Changi Airport, right? We have these little robots. Okay, not quite little, but these robots, right? Moving around, right? They are known as the Avid Bots Neo. Okay, so these robots, if you were to notice them, that's good. If not, you can actually uh, go down to Changi Airport, take a look at them. Okay, so they'll be around, cleaning around the whole airport, right, in a very autonomous manner. And of course, the second example, right, the Xiaomi Mi robot, this is a little bit more popular, okay, and it's usually used for to clean up our uh, floors in our house. Okay, so more on that later. All right, so I have a visual illustration on this. And of course, the last example in the leaf category, we have the self-driving cars, right? Level 2 to 4. Okay, so we have example based on the company Waymo. Okay, so we have a video example on this later on. Okay, so that's all for the leaf category. Moving on, we have under the work category examples like in the hotels service robots, right? Like in Hotel Gen, right? They have service robots that helps to serve guests. Okay, and on the second example, we have the Boston Dynamics Pick System. Okay, so these are industrial robots that is able to do pick and place tasks, right, especially on heavy packages. Okay, so I have a visual illustration on this as well. And the last example of under the work category, we have the humanoid nano robot. Okay, so in some other cities, this robot, or rather this highly intelligent robot, is being used to teach students on low-level subjects. Okay, so that's all for the work category. We'll move on to the play category. Right now, as you can see, right, some of the companies, they have developed chess playing robots. Okay, and of course not in the software form, right? In the physical form where there's this humanoid-like robot playing chess with you physically. And of course, second example, right? We have this robot cup competition, right? This is sort of like imagine a soccer game with just robots only. Okay, so I have a video example on this for better visual illustration. And of course, the last example in the play category, we have robot dogs. And one of the example of robot dogs is this robot called Aibo, right? And it's developed by Sony, right? So if you are interested, you can actually watch some of the clips of this robot dog. You actually find that the way it behaves is pretty much similar to the real dog. Okay, so further ado, there's several examples that I will go through. Okay, on the visual aspect. Okay, there's not enough time to go through every example. Okay, so let's move on to the some of the visual illustrations of these examples. Okay, so for example, Xiaomi Mi robot, as I mentioned just now, is a vacuum or rather a robot vacuum cleaner. Okay, and I think maybe some of you guys already have this. Okay, so bear with me if you already have this. Okay, and if let's say you do not have, it's okay. All right, I'm here to briefly explain to you. Okay, so what this robot vacuum cleaner can do for you is that it can actually map out, all right, your whole house. Okay, with the help of the lidar sensor on top. Okay, so lidar sensor, the main purpose of it is to detect nearby obstacles. Okay, so with that data, it's able to build a map. Okay, in our terms, is known as SLAM. Okay, simultaneous localization and mapping. Okay, so with SLAM, okay, the robot is able to map out the whole house, and with the map data, the robot is able to build an efficient cleaning path. Okay, as you can see from the picture over here. Okay, so with this cleaning path, the robot is able to cover almost every corners of the house, thereby making it clean. Okay, so that's all for the Xiaomi Mi robot. Okay, I'm not actually promoting, right, for you to buy. Okay, if you are not aware, this robot is rather expensive, around $300 SGD. Okay, so if you're interested, you may want to look at it. Of course, the next example, all right, is self-driving cars. Okay, I know most of you might have heard of it before, uh, and might have hear from your friends or hear from other people, but might not have experienced it firsthand before. Okay, so I have a video here based on way more self-driving car. And for those who have not heard of Waymo before, Waymo, it is used to be called the Google self-driving car, right? That was before it was rebranded into Waymo. And even though it was rebranded, it is still under the Alphabet company, right? So effectively, it's still under Google. Okay, just a bit of rebranding there. Okay, so right now I'm going to play this video along the way. Okay, please enjoy this driverless experience.
Driving by itself. There's no driver, Daddy. See?
That is nuts.
It's pretty crazy. It's like there's a ghost at the steering wheel.
Kind of feel like royalty being paraded around in this thing.
School zone.
Look at these guys. Looking over.
Are they?
No driver.
Go!
What?
This little Waymo thing is cruising.
Oh, it's a pretty sharp turn. They made it pretty smoothly.
Thank you. Do I say thank you?
We're here. We made it.
and I didn't have to drive.
Okay, so I hope you enjoyed that video. Right, so something to take note is that you must understand that this is an advertisement video, okay, to promote way more brand. Okay, and of course, though it may seem very flawless, okay, there's several things that they have not pointed out. So, for example, if you look at the video, okay, there's no driver behind the wheel. Okay, but in actual fact, for level 3 or level 4 self-driving cars, okay, a driver is still needed behind the wheel, and that's because such cars, right, has still limitations. Okay, when I mean by limitations, meaning that it is only able to drive within its comfort zone. Okay, so be it a limited area, right, limited geographic area, right, that the self-driving car is able to drive within, or either that maybe within certain conditions, for example, certain weather conditions or certain speed limits that this group of self-driving cars is able to function. Okay, so in the event that, right, that this group of self-driving cars goes out of this comfort zone, the human driver will have to take the wheel and intervene. Okay, so just please take note of that. Right? Do not be fooled by the video. Right. Okay, so the work example, right? In the work category, as I mentioned just now, Hotel Jen has two robots moving around, and they're responsible of delivering food and other items, right? That you order from room service. Okay, so if you have a chance, right now we are unable to travel. With chance, you might want to do a staycation at Hotel Jen. Okay, and if you do, please observe these robots running around. Okay, Jano and Jana, right? And if you can, right, order some room service and wait for these robots to serve you. Okay, so another work example, as I mentioned just now, Boston Dynamics peak system. So these big robots, they are usually used for uh, industrial use, for example, for warehouse and logistics industry. Okay, where they do pick and place of heavy packages. Okay, and the good thing about this robot, which is also why I put in this example, is that it is one of the first autonomous robots that are being made. And not only that, it is very dynamic in the sense that it is able to handle of different packages. Okay, so even if, let's say, the packages change, okay, not necessarily it has to be handling a certain package. Okay, the package can change, the weight can change. Okay, is able to be very dynamic in that sense. Okay, so moving forward in the last category, play. Okay, we have chess playing robots around. Okay, these are already being made. Okay, and I'll say this as compared to playing on your computer has a different feel, especially for chess fanatics. Okay, because chess fanatics, they really want to feel the physical pieces. Okay, and at the same time they want to play with someone. Okay, if let's say they cannot find anyone to play with. Okay, so the chess playing robot can solve this problem, right? Fulfilling these needs, right? And able to play with the human on the physical manner. Okay, and the last example under the play category, we have this robot cup competition. So as I mentioned just now, imagine soccer with that involves, right, all robots playing the soccer game. Okay, and this particular competition here, right, in this video, it is held in Sydney, Australia. And if you look at the video later on, one of the objectives of the organizer is that they want to build a team of robots that is able to beat a human team by the end of year 2050. Okay, so I'm not sure whether that's too ambitious. Hopefully they are able to achieve that. Okay, but if they're really able to achieve that, right, that would be very interesting, and I think that would be very good for the entertainment industry. Okay, at least something new and something interesting to look forward to. Okay, so I'll play this video. Please enjoy. All right, so I hope you enjoyed that video. Okay, so hopefully this will work out, right? So that maybe in the near future, okay, we're able to see a group of robots playing soccer with each other. Okay, at least an option as compared to watching a Euro Cup or the World Cup, right? Right, maybe we have a robot cup on the international level. Okay, so that's all for the present application. Right now, we'll move on to the futuristic ones. Okay, in the same three categories: live, work, and play. Okay, so under the live category, robots, right, that can help us do our household chores, right? Currently, it's not available, but I believe in the near future, it will be possible. Okay, especially robots that is able to be involved in the healthcare industry and also to act as a social companion to the elderly. Okay, so I believe this is currently in development and hopefully it will be commercialized soon. Right, and last but not least, under the leaf category, right, level 5 self-driving cars. Okay, so to my knowledge, Tesla recently announced that they would build a team to move towards this direction, right? Level 5 self-driving car. Okay, so later on, I have a video to do an illustration, a better illustration on uh, some examples of the level 5 self-driving car, all right? But of course, that's based on a science fiction video, all right? So bear in mind. And moving to the next category, under the work category, we have we would like to have robots that able to help us do manual heavy tasks, okay, as well as robots that is able to help us to cook, okay, and lastly, robots that is able to do surgery, all right, in the operating room, okay. And the last category, play, okay, it will be interesting to see a group of robots playing music for us, right, keeping us entertained, as well as robots dancing around, okay, doing parkour or doing flips and some sorts. There are robots that are able to do that right now, okay, but maybe not yet, okay. So I would like to see that in the near future. That would be interesting. And of course, the last example under the play category, robot wrestling, okay, which I will explain a little bit more later on. Okay, so for the leaf example, right now I'm going to play this video. Right, it will be a representation of the level 5 self-driving car. Okay, and this video is adapted from the TV series Black Mirror. Okay, and why I chose this video is because the level 5 self-driving car, though is fiction here, right, it is a very accurate representation of the ideal version of the self-driving car, or rather the level 5 self-driving car that we want to achieve in future. Okay, so please take a look at this video, and while you watch this video, please observe what's the difference between this level 5 self-driving car. First, the level 3 and 4 self-driving car, which I presented to you earlier on. Right, so please try to make that observation while you watch this video.
Got them.
Are you Batman? There.
Let's go.
We can take house for terrorist informers usually.
Rasmus?
I just picked up an attempted breach.
Okay,
Rasmus got a track on them.
Not yet.
Okay, so I think you have a rough idea, okay, and I mean a rough idea of what's the difference between level 5 and level 3 and 4 self-driving car. Okay, I think the obvious observation which I believe that you have made also is that, okay, that there is no driver seat. Okay, there's no wheel and there's no driver, okay, to take over in the event if, let's say, the self-driving car will not be able to drive. Okay, and of course, because of that, the seats are facing each other, right? So they are able to communicate and interact face to face, right? As compared to the current car structure right now. Okay, so seems pretty cool, right? Hopefully that will come out eventually. Okay, so that we do not have to drive, and we are able to do our own thing while doing our car journey. Okay. So of course, under the work category, right? Uh, Humanoid robots, right, is able to help us do laborious tasks. Okay, for example, carrying heavy packages from one end to another. Okay, and if you look at this particular robot over here, right, this robot is known as Atlas. Okay, Atlas, right, developed by Boston Dynamics. Okay, developed by Boston Dynamics. Okay, and for those who are very familiar with humanoid robots, right, you will understand that for a humanoid robot to do such tasks, right, is pretty impressive. Okay, because most of the humanoid robots out there, right, when presented extra masses, right, they will tend to be very unstable and they cannot perform their tasks properly. Okay, but this Atlas is able to, right, even though when carrying heavy masses, right, is still able to maintain its stability. Okay, so I hope maybe in future when more of these humanoid robots are around, okay, it's able to help us do all these laborious tasks, okay, which may not be so suitable for humans to do. And finally, the last example and the last category, okay, under the play category, right, robot wrestling. Okay, so if you look at this poster over here, okay, so this poster is actually adapted from the movie Real Steel. Okay, so if you have watched it, bear with me. Okay, if you have not, you might want to watch it. Very interesting movie over here. Okay, so just a very brief synopsis is that this particular movie is based on a future event whereby robots uh, replace humans, right? Replace humans in the wrestling ring. Okay, so instead of having humans in WWE events or MMA events, okay, we have robots, okay, fighting each other, and this actually keep entertained. Okay, so I'm not sure whether this kind of entertainment form will come out anytime soon. Okay, hopefully it will. Okay, that will be very interesting. All right. Okay, so that's all for all the examples for the application. Okay, so right now, just a brief introduction of some of the state-of-the-art technologies, right, to let you have an overview of some of these technologies that are used within intelligent robots. Okay, so firstly, right, thanks. Okay, so the first one, LiDAR sensor. Okay, so LiDAR, it means light detection and ranging. Okay, so the LiDAR sensor, as I mentioned just now, it help us, or rather help the robot to detect nearby obstacles. Okay, and the mechanism of it is that this LiDAR sensor, if it's a 360 type, it will keep rotating. And while you rotate, it will shoot out light beams, hit the objects, and receive it. And from this data, it will calculate the distance of the object from the sensor. And following which, we have machine vision technology. Okay, so I take this example from Tesla Autopilot, right? Tesla Autopilot, autonomous vehicle. Okay, so to put the story short, all right, Tesla has a superior technology when it comes to machine vision technology, right? In the sense that because it's very reliant on cameras, which weakness is that under adverse weathers, right? Under adverse weather conditions such as rain or under darkness, okay, the cameras most of the time will not be able to function properly. Okay, but Tesla somehow they are able to solve this problem, okay, by using their own algorithms. Okay, so let me move a little bit faster. And of course, we have brain control robots. Okay, so this project is done by MIT. Okay, so with an EEG sensor, the person is able to control the robot just by using his brain waves. Okay, and the last thing I want to share with you, right, in terms of state-of-the-art technologies, is this thing known as ROS. Okay, Robot Operating System. Okay, so to put the long story short, okay, Ross, this article by Bloomberg, in summary, is actually saying that Ross has potential to become an industry standard, okay, especially in Singapore context. Okay, so for Ross, all right, just bear in mind it's not a conventional operating system, meaning it is not like your Windows or Linux or iOS. Okay, ROS actually runs on all these existing operating system. And the whole idea of ROS is that we do not want to reinvent the wheel. Okay, which means to say if we have packages being done on, for example, like Ubuntu, and if we want our robotic system to be done on OS, for example, okay, there is no need to recreate the package, okay, in OS just to do the same functionality. Okay, so with ROS, I'm still able to run my robotic system on OS, for example, at the same time able to connect, right, with another package that is running on Ubuntu platform. Okay, so that's the beauty of ROS in summary, right? It does not, right, let us to reinvent the wheel. Okay, so a little bit faster on this section, right? Just introduction on the Turtlebot 3 as well as the Open Manipulator X. Okay, so Turtlebot 3, it is ROS compatible and able to perform SLAM and navigation and is able to be configured into a highly autonomous robot. Okay, so Turtlebot 3, this is how it looks like. Okay, it has a 360 LiDAR on top, right, with a Pi camera over here. And it contains a microcontroller as well as a a single board computer. Right? In this case, we use Raspberry Pi. And for the open manipulator, okay, we have the robotic arm. Okay, this is also ROS compatible. And the good thing about it, it can be attached onto the board tree like this, right? And work as an integrated system, right? So effectively, this robot over here, it has the best of both worlds, able to move around, being a mobile robot, at the same time able to manipulate objects around it. Okay, so effectively, it's a two-in-one manipulator and mobile robots in one system here. Okay, so last but not least, let me run through the live virtual demonstration. But before I do that, like to show a physical demo. And of course, because of due to the current situation, we have recorded this, right? And in order to show you the physical demo of the bot tree, right? So please enjoy this video. Okay, so that's all for the physical demo. Okay, right. If there's a chance, you may come over to NUS ISS. We can give you a live physical demo. Okay, but nevertheless, right now because it's on virtual mode. Okay, we can only give you a live virtual demonstration, right? And just a very short demonstration over here. So we have a very dark environment being portrayed, right, in the Gazebo simulation software. Okay, so don't mind here because just for your visualization purpose, okay, we have switched on the light. Okay, but later on during the demonstration, you'll see that it's very dark environment. Okay, and over here we have the turtlebot, right? The blue color lines, these are represent, or rather visual representation of the LiDAR scans, okay, or the laser scans done by the LiDAR sensors, okay? And if you look at the right side, okay, this is the map that's generated beforehand, okay, done by SLAM operations. Okay, so doing the demonstration will not show you that how the SLAM is being done. Okay, just bear in mind that the SLAM is done already beforehand. So map data is already collected. And right now we're going to show you based on this map data that is generated from the SLAM, how the robot is able to navigate through this maze over here, even without uh, any light, okay, just with the LiDAR sensor and as well with the help of the map, okay, with the help of the map data. Okay, at the same time, please observe that the robot, right, is able to reach to its destination, which is at the top right. Okay, so the initial point will be at bottom left. Okay, so a robot will move through the maze and to its final destination without hitting into any objects, right? So it's able to perform path planning as well as collision avoidance. Okay, in this example over here. Okay, so I'll switch to my Ubuntu platform for the demonstration. Okay, so first of all, I'll launch the Gazebo world, okay, known as the dark world. Okay, So effectively, this is just a maze under a very dark environment, right? Which I have off the lights to simulate that. Okay. So over here, okay, bear with me a while I maybe switch on the light for a short while just for your visualization. Okay, so you see here, this is the map being generated in the Gazebo simulation software. Okay, the turtlebot tree is on the left, bottom left. Okay, so this is the initial point, and it has to move through this maze to the top right over here. Okay, this will be the end point. Okay, and as I mentioned just now, all these blue color lines over here, they are the laser scans. Okay, so let me run the navigation node to show you that. Okay, so now I'll remove the light and I'll run the navigation node. The navigation node, okay, the robot will begin to plan a path, okay, from the initial point to the end point, while at the same time avoid any obstacles along the way. Okay, so for those who are not familiar with these RVs, okay, RVs is just a visualization tool, right? So that we're able to visualize some of the things that the robot is doing. Okay, so let me just remove right, some of these so that you're able to visualize properly. Okay, so you see the robot start moving, right? And this map, right, as I mentioned just now, is previously generated by SLAM. Okay, and if you see over here, okay, sorry, 1 minute. Let me orientate this orientation. Okay, so as I mentioned, you move from the bottom left, okay, and you will run through to the top right. Okay, so let me on the light just for you to visualize that. Okay, so I will not wait for the robot to finish its navigation. Okay, with this, I think I'll end my demonstration. All right, thank you very much for your time. Okay, and I hope to see you soon. All right.
Are there any questions from the floor? I think can maybe the last minute. Yep. Maybe then we can end this session. Clarice can just take over then.
For the great sharing and insights. We have come to the end of this session. Thank you all for attending. We would love to hear some of your feedbacks. You'll be provided with a survey right after this session, and do give us your valuable feedbacks. Thank you once again for joining us, and continue to enjoy the rest of the sessions today.